Hey guys, thanks for tuning in. And yeah, this channel is all about sharing my learnings, you know, to have my own set of resource library, uh, topics which I can come back to and revise. So yeah, this is mainly to improve my speaking abilities and presentation skills. So yeah, any interesting stuff that I learn, so I'll be sharing it over here. So yeah, feel free to watch the other videos as well. Okay, so today we are going over a system design overview of URL shortening service. Uh, Mainly, you've come across Tiny URL or Bitly. So these services basically take in your long URLs and they shorten it, and yeah, they really make a uh, use case for sharing the URLs. So that your long URL is not really cluttered, and you can share it easily uh, with others, right? So yeah, that's basically the functionality of it. So we are gonna quickly write it down over here. Okay, so let's start with our functional requirements. Okay, so first it is just going to convert our long URL to a short URL, and secondly, like whenever a short URL gets hit, so it has to redirect to the original URL, right? So yeah, that is so one of the functionalities that we are going to focus on here. So from short URL, we are just going to redirect. Okay, so yeah, uh, so coming to the non-functional requirements. So in the cap theorem, I think we can prioritize availability here, because as soon as I create a short URL, like it's fine if it doesn't work right away, but I do want it to work consistently in the future. But yeah, but the system has to be available, right? So I think we can prioritize availability over here. Okay, so we are going to prioritize availability. And of course, we are going to have this system running on as low latency as possible. So that is of course going to be our focus, right? Okay, so yeah, this seems pretty fine to me. Okay, so coming to the capacities and estimations, let's say let's just assume we have a user base of around 100 million daily active users. So our system is going to be much more read heavy, right? So let's assume around 20% of these users are going to actually create tiny URLs. So um, let's take 20%. Okay, let's just first calculate for the writes. Okay, so let's say around 20% of our users are going to be actually writing onto the system. So and let's say each user creates like 2 or 3 URLs. So let's assume 2. Okay, so this comes around 40 million writes per day, right? And if you want to convert this into per second, so we just multiply it with 12. So whenever we have millions per day, we can just replace it with 12. So it comes around 12 plus or minus. So I just take it as 12 just for the simplifications. So it's going to be writes per second. so it is going to be around 480 writes per second. And coming to our rates, it is going to be 80% of our daily active users. So we can just say each user requests maybe 4 or 5 times a day. So yeah, we can have this. So it comes around 400 million rates per day, and converting that to seconds, we can have again around 5,000, we can say, reads per second. And coming to the storage part, let's say each of our record utilizes maybe 2 KB of our data. So we have 40 million. So we have 40 million writes per day, and each of those writes is going to consume like 5 KB of our data. So that comes around 800, 10 to the power 6, 10 power 3 bytes, and this comes to 3 power 9, and we can have this 3 power 9, 3 power yeah, let's just leave it at 3 10 to the power bytes. So this will be around this is going to be I think gigabytes, 800 gigabytes per day. Okay, so coming to the APIs, so we're going to have 2 main requirements over here. One is to create a resource, and another is to check if the short URL already exists in our system, and then to redirect. So the first one is going to be our creating the short URL. So it's going to be a post request. So create short URL, it is going to be our post request, and it's gonna look something like API slash URL slash generate maybe, and we are going to send in our long URL in the request, and we are going to receive short URL as a response. Okay, so coming to the second API is that we want to check if the URL already exists in our system. So we are going to have a get request to check that, and yeah, it's going to look something like API slash URL slash short URL, and in response we are going to get the long URL. Yeah, these basically are the 2 APIs which are going to cover our functional requirements. Okay, so let's get started with the design part. And yeah, of course, these 2 are the main services that we are going to have. One is to create a short URL and another to redirect. So I'm just going to separate out these two services at the beginning itself. So maybe at this point you may wanna fast forward the video, because I'm gonna take my sweet time over here to draw out these services. But yeah, you're free to watch, of course. So yeah, let me draw this as well. Okay. Okay, so I'm gonna have two services over here. One is create URL. Maybe I want to write short URL. Then I want this service to redirect, right? Yeah. So we have this. Then we have load balancer to navigate this request to the right services. So we are going to have our okay. I'm just going to have my load balancer over here. So whenever our user is going to hit our services, it's going to decide if we want to route this request to create resource, or we want to redirect it to the redirection services, right? So of course, whenever we create a URL, we of course want to store it in our database. So we're going to have our database over here. And okay, so whenever we create a new short URL, of course we want that to persist in our system. So of course we are going to have it stored in our database. And this again is really an open-ended question, like what database I'm going to choose here. But I think a SQL based database would be a good option here, because we don't really have to scale that much. And of course our schema is going to be fixed. So I think a SQL based database would be a good option here. But of course it would make sense to have a database like MongoDB as well, because we don't really have to worry about the consistency. So yeah, this is like a open-ended question here. So yeah, I would prefer it to be a SQL based database. So yeah, I'm going to continue with that. And coming to the create short URL service. So I can think of a couple of ways to actually create these tiny URLs. So I'm going to discuss this. So first thing is, whenever we have a long URL, say XYZ ABH, like something like this, so we can basically hash this and generate a 4 or 5 character long URL. So that would make sense. That would make sense to have this entire thing hashed and just create a hash function out of the input URL. Okay, and again there is a possibility of collisions over here, but yeah, this should work fine, I believe. In case of collision, what we can do is we are going to check if this short URL already is in our systems, and if it is there, then we can rehash the URL with some additional input, I think. So yeah, so let me just talk about what our database structure is going to look like. So I can of course have short URL as our primary index. So we can also index this, and it would make it much more easier to search if our hashed URL already exists in this database. So short URL would be our primary index, and we can have the corresponding long URL as well. Then we can have a timestamp at which it was created, and I think I can have user ID if possible. And let's just say these are the columns that I want to have. So if we index it on the short URL, it would make it would be much more faster to check if the hash already exists in our database, and if so, then we can rehash it. Another option that I can think of is we can have like a counter value which we're going to hash instead of the input URL, so that would be unique, and that would also make sense over here, I believe. So we can have a counter service, we can have a counter variable stored in our cache here. That would make sense. So we are going to get our counter value from this hash. Let's just say we are going to use a system like Redis over here to have this value stored over here. So we can check the counter value, and based on the counter value we can uniquely create URLs, right? So at the beginning of the system, for an example, let's say our counter value is 0 at the beginning of the system. At the end of the day, it comes to around, like, say 10,000. Okay, so of course this value will be unique, and we can use this value to uniquely hash our short URL, right? So that's pretty much it. So whenever we create a short URL, I think whenever a short URL is created, we want to store it in our database. And whenever our service gets it with the short URL, we want to redirect it. So this function is going to search our database for that, for the URL. If it is present, it is going to redirect, otherwise it is just going to return with the bad value. So also we can have a caching mechanism over here, so that if we don't find the short URL in the cache, we can hit the database. So that would reduce the database hits for us. So we can have like a cache system over here. So if you don't find it, we can hit the database. So this pretty much covers our main functional requirements, I believe. There are other videos out there which discuss a lot of other functionality in the functional requirements as well, like analytics and the time duration for which we want to persist that the short URL, but I'm just going to not discuss that, because of course I don't think I know about it that much in detail. And this entire explanation seems to take up more time, and there can be a lot of questions around this system as well. I have left quite a few rabbit holes here and there, so of course we can ask questions to optimize this system a bit. And this is just going to be my design for this So hope you guys liked it. And yeah, any suggestions, feedback for me, I'd be happy to hear them out. Yeah, thanks for your time. And yeah, see you guys later.